Hello everybody, this is Todd Frazee again, and here is the video tutorial for the S60-107 CAD portion for the bushing part. So in this assignment, again, you can access the drawing by selecting on the PDF, and if you choose to, you can print it. The part looks like this. It's another brass part. If we look at our drawing, it has a diameter call out and a call out for a through hole. And down in our materials it says it's actually not brass, it's actually 544 bronze, quarter hard, and it's an alloy of copper. Our revision is 0. So we want to go to SolidWorks and we want to create a new folder. If you first launch SolidWorks, it's going to give you a menu that looks similar to this. So we're making a part file, so make sure that's selected and select OK. And then we have our default window. You might have a help screen over here that you can minimize if you need to. So we're going to start off as we did before in our previous ones. We're going to first go to Sketch, and before we do anything else, we're going to save our part, and we're going to save it as the part number with the correct revision. So in this case it's 107, and we're going to double check our drawing. It is revision 0. And then you have your first initial and last name. Now you notice we're not necessarily developing these parts in numerical order. I have the parts on your assignment list in Canvas in the order of complexity, and there's no correlation with the actual part number. So don't worry about it. You should have already developed the -109. And now we're going to do the 107, which has one more feature than the 109. Okay, so let's hit save. And again, you want to save in your H drive. And let's go ahead and make our 3 planes visible. And if we look at our part that we're developing, it's another cylinder, and it has a hole going all the way through it. The way they set it up in the drawing, this would be your primary view, and this would be your secondary view in the right side viewing plane. So we're going to go ahead and model this with this in the right side drawing plane. It's a very small part. This is actually the physical 100% 1-to-1 size of it. This image has been scaled up 4-to-1 to make it easier to read. Okay, so what we need is we're going to create 2 circles and extrude those for this method. So we're going to have 2 features defined by a single sketch with this method. Okay, so we're going to go, again, we go to sketch mode, and we're going to press the sketch icon, and the first thing it does is select a plane in which to create a sketch or entity, and we're going to do it in the right side plane. And our entities is we need 2 circles. So we're going to hover over origin till we see the coincident symbol show up, because we want our circles to be coincident with origin. Okay, so we're going to draw a second circle, and if we did that correctly, I should be able to exit the circle command, and you can use the escape key on your keyboard to do that. We should be able to try to pull on the centers of these circles, and they're not going to move anywhere. They both need to be constrained for diameter, but their positions are constrained at origin, and in effect they're concentric to each other, so you don't need to put those relationships in. Alright, so now we're going to go reference our drawing again, and the larger diameter it needs to be between 0.238 and 0.236. That's the allowable size of that. So what do we do when we model this? We can't put 2 numbers in. We are going to model, always in this class, to the average or mean of the tolerance. So the average or the mean of the tolerance. In industry, that's often called the nominal dimension. But there's some confusion in industry about the actual definition of nominal, and we'll get into that later. But halfway between 0.236 and 0.238 is 0.237. It's an odd number. So we want to draw the model at the medium of the tolerance so that when we set this up on the machine, we have plus 1,000th and minus 1,000th. Your base program will be at the mean of the tolerance, and any adjustments for tools can be done at the machine based off the program set up to cut theoretically perfect. So that's how we want to model. Okay, so we're going to make the diameter of this outside circle 0.237, and you can either select the green check mark or hit the enter key, and that turns black, so it's fully constrained. Now you notice it says 0.234. That's because the default tolerance is at 2 places, so we're going to change that to 3 so that it doesn't round up. Now, how do we get this to display the tolerance the way it did on the drawing? This isn't critical in the modeling stage, but it'll save you on the drawing side. If you pick on the tolerance type and select limit, and that gives you 2 numbers, and you're going to say your limit is plus 0.001 or 1,000th, and your low side tolerance limit will be 0.001. So in effect, we get the same display as we have here, but our actual model is 0.237 inches in diameter. So if we go and measure the model or drive toolpath on it, it's going to run right at the center of that tolerance. Okay, so we're done with that dimension. Let's do the dimension for the center circle. We're going to go back over, and it has a similar range, 0.96 to 0.94, and nominal, or the mean of the tolerance, for this dimension would be 0.095. .095, and it's actually 3/32. So that's actually, we're going to put in 3 divided by 32. And it's going to say 0.9, but if we extend this out to 4 or 5 decimal points, you're going to see that that's a true decimal equivalent of that number. And we're going to go with limit, and we're going to give it a plus or minus 0.001 or 1,000th of an inch tolerance. By the way, the human hair is 5 to 7 of these units in diameter. Okay, so we can still have the actual raw display units show multiple decimals, but then the tolerance limit is still at what it should be, which was what the drawing was, 0.123. And we're going to select OK. Now both those entities should be black, and if we are to look at our sketch, we don't have a negative symbol over here. So we should be able to hit, you're going to select the exit sketch icon. And if you have a negative symbol here, you need to go back and fix something. Okay, now we're going to go back to features, and we're going to do another extrude boss. And it's asking you, do you want to create a new sketch or do you want to select something? Over here, the feature tree is temporarily displayed if you pick on the down arrow, and we're going to select the entire sketch feature off the tree that we just created. and its default is to make it 100 thousandths thick. Let's go back to our drawing, and it is 301 thousandths thick. So we're going to go back to SolidWorks, and we're going to put in 0.31. And that gives us the proper length to the drawing. We're going to accept that. And here we have our bushing. Alright, so like in the last tutorial, we're going to go and set our material. Right click on it, edit material, and it is a copper alloy. And I don't know if they actually have bronze. Tin bearing bronze. That's probably, it is a bearing, so I think it is a tin alloy bronze. And we're going to apply that, and the color should change. Okay, so we've just finished the model and applied its properties to it. Okay, we're pretty much done with this part. As you can see, we've got the model with the bushing and the hole going through it. All right, good job. I'll see you on the next one.